Hello, I'm Cherish Rose with Simpson Math. Today we are going to be graphing a polynomial with irrational roots. Our polynomial is quadratic. The first thing we're going to do is find the end behavior. Our leading coefficient is a -1. The negativity tells us that it's going to fall to the right. The degree of our polynomial is 2. 2 is an even number, so that tells us that it's going to exhibit the same behavior on the left as it does the right. Since it falls on the right, it's also going to fall on the left. The degree of our polynomial also gives us information about the number of terms and the number of roots. The number of terms is always one less than the degree of our polynomial. So 2 minus 1 equals 1 term. And the number of roots is always the same as the degree of our polynomial. So we have 2 roots. And from this information, we can get a rough sketch and estimate of what our function is going to look like. It's going to fall to the right, it's going to have 1 turn, and it's going to fall again on the left. The second thing we're going to do is find our y-intercept. To find the y-intercept, we change our x's to 0. So we have x equals 0, which is going to give us f of 0 equals -0 squared plus 8 times 0 minus 5, which gives us -5. We know that there's going to be a point on our graph at 0, -5. The third thing we're going to do is find our x-intercepts. To find our x-intercepts, we change our y to 0. So we have 0, -x squared plus 8x minus 5. Before we do anything else, we're going to try to factor by using the AC method, where our a is -1 and our c is -5. The factors of -5 that equal or add up to be 8, well, there aren't any. So we're going to have to break out our secret weapon, the quadratic formula. The quadratic formula states that x equals -b plus or minus the square root of b squared minus 4ac, all of that over 2a. Now we're going to plug in our values where a is -1, b is 8, and c is negative 5, which is going to give us x equals negative 8 plus or minus 8 squared minus 4 times 1 times negative 5 over 2 times negative 1. And now we're going to simplify. X equals negative 8 plus or minus the square root of 64 minus 20 over negative 2. We're going to simplify again. X equals negative 8 plus or minus 44, the square root of 44, over negative 2. We're going to simplify once more. X equals negative 8 plus or minus the square root, or 2 on the square root of 11 over negative 2. Now we're going to separate this and divide. X equals negative 8 divided by negative 2. 2 on the square root of 11 divided by negative 2, which gives us 4 plus or minus the square root of 11. When we break this apart, we find out that we have 2 points on our graph. One at 4 plus the square root of 11, and 0, and 4 minus the square root of 11, and 0. The next thing we're going to do is find our axis of symmetry. To find the axis of symmetry, we simply use a shorter version of the quadratic formula, which states that x is equal to negative b over 2a. Since we're using a shorter version of the same formula, we should get the same result, which is this 4. So let's try it. Negative 8 divided by 2 times negative 1 equals negative 8 divided by negative 2. And sure enough, our axis of symmetry is equal to 4. Our axis of symmetry is a vertical line where x equals 4 and our quadratic is going to fold around it. We can also find our vertex on the axis of symmetry. To find the vertex, we take the value of our axis of symmetry and plug it into our function to find our y value on the axis of symmetry where x equals 4. So to find our vertex, we're going to find that f of 4 is equal to negative 4 squared plus 8 times 4 minus 5, which is going to be equal to negative 16 plus 32 minus 5, which is going to give us 11. So we have another point on our graph at 4, 11. Finally, we're ready to create our graph with all of our points. Our y-intercept is at 0, -5. 1, 2, 3, 4, 5. Okay. 0, -5. Going to be sure to label all of my points. Our vertex is going to be at 4, 11. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's going to be somewhere right here. 4, 11. We know that our axis of symmetry is on this 4. Oops, I went over too far. Our vertex should be right there on the 4. I'm going to go down with our vertex. And since our axis of symmetry is the line where our quadratic folds in half, we should have a point on the other side of our axis of symmetry. 1, 2, 3, 4. 1, 2, 3, 4. This is our additional point at 8, -5. Now we're going to find our irrational roots on our graph. We know that the square root of 11 is somewhere between the square root of 9, which is 3, and the square root of 16, which is 4. It's closer to 9 than it is to 16, so we're going to say that that 11 is 3.2. So 3 and a little bit. Starting at our axis of symmetry, we're going to move over 1, 2, 3, and a little bit to find our 4 plus the square root of 11 and 0, x-intercept. We're now going to move backwards 1, 2, 3, and a little bit to find our 4 minus the square root of 11 and 0, x-intercept. I'm going to make my dots a little bit bigger so we can get a better drawing of our quadratic function with this distinctive parabola shape. And that is how you graph an irrational root, or a polynomial with an irrational root. Math Made Simple by Simpson Math. Thanks for watching.